Today we're going to learn about bar graphs and how we can solve problems using bar graphs. These are some different types of graphs. There's a tally chart, a picture graph, and a bar graph. Graphs help us organize data. Let's watch a video about bar graphs to learn a little bit more.
Where should we go on our next class trip? The zoo, the firehouse, or the apple orchard? I'm taking a survey and making a tally chart. What are surveys and tally charts? A survey is a list of questions used to collect information or opinions. Let's see. There are 3 dinosaurs here. Let's take a survey to find out which one our classmates like best. We can use a tally chart to record data or information. Let's see. Moby likes the Stegosaurus the best. You can draw 1 tally mark to stand for 1 vote. 5 kids like the Triceratops. So I'll draw 5 tally marks in that row. 1, 2, 3, 4. The 5th mark is drawn across the other 4. Well, when you group the tally marks by 5s, you can count by 5s. 5, 10, 15, 20. Sets of 5s are easier to count. 7 kids like the T-Rex. So, after I draw 5 tally marks, I can add 2 more to make 7. Oh, right. I forgot to vote. My favorite dinosaur is the Triceratops. I'll add a tally mark to that row. It's really easy to add to tally charts. Now I can count the votes and use the tally chart to make a bar graph. What is a bar graph? A bar graph is a way to organize and show data. You can write the categories on the bottom. The 3 dinosaurs are the categories. Then you can write the numbers on the side. The numbers in our bar graph show how many people voted for each dinosaur. Let's see. 1 student liked the Stegosaurus the best, so I fill in 1 square. 6 people voted for the Triceratops, so I color in 6 squares. 7 people said the T-Rex was their favorite dinosaur. You can also put the categories on the left and the numbers on the bottom. You can display the same information in a different way so you can understand it better. How can you use bar graphs to understand information? Bar graphs help you answer questions. Which dinosaur did people in our class like the best? Right, the T-Rex is the most popular. Which dinosaur did people like the least? The Stegosaurus got 5 fewer votes than the Triceratops. You can even use the bar graph to figure out the total number of students who voted. Just add the votes from each category. 14 kids voted in all. I'm almost done with the survey on where to go for our next class trip. So far, the zoo is the most popular. It has 16 votes. But I don't have your vote yet, Moby. Where do you want to go? The moon? I don't think the bus will get us there.
Our learning target today is I can read and draw a bar graph to represent a set of data and use it to solve a problem. Let's do our mirror words. read and draw bar graphs to represent a set of data and use it to solve a problem. Let's do that one more time. I can read and draw bar graphs to represent a set of data and use it to solve a problem. Mirrors off. Great job learning your I can statement today. Make sure you go share it with somebody else. Let's review about the parts of a bar graph. At the top of our bar graph, we have the title. This tells us what the graph is about. Down here, we can see what is being compared. So the types of treats. This is our x-axis title, and this is what we collected data about. Our categories are the different types of treats: cookies, candy, ice cream, and fudge. Our y-axis title shows us who we're collecting the information from, so the number of students. Our scale shows the amount of the data, and it must start at 0. Our bars show the data that's been collected. So 4 students like cookies, 3 students like candy, 6 students like ice cream, and 2 students like fudge. Now let's practice solving some problems using bar graphs. Here we have a bar graph of animals at the wildlife park, and it's a different type of animals and how many there are. So we have lions, bears, tigers, and monkeys. 4 of the monkeys are adults, and the rest are babies. How many of the monkeys are babies? Well, let's look at our monkeys first. We know that we have 6 total monkeys, so that's our total. We know that 4 of the monkeys are adults, so that is one of our add-ins. We don't know how many there are that are babies. We just know that it's the rest. So we can solve to find our missing addend. I can do 6 minus 4, so my total minus my addend to give me my missing addend. And 6 minus 4 is 2. So there are 2 baby monkeys. Let's try another problem. How many fewer bears are there than monkeys? So I'm going to compare my monkeys to my bears. I know there are fewer bears than monkeys, which means that there's more monkeys. So I'm going to make a comparison bar for my monkeys and my bears, and then find out how many fewer there are. So I have 6 monkeys and 4 bears. So I need to figure out how many fewer there are. Again, I can subtract 6 minus 4, and I get 2. So there are 2 fewer bears. Let's try another problem. There are 2 fewer lions than elephants. How many elephants are there? Well, I see where my lions are, but I don't have elephants on my graph. So I'm going to have to use the information from here to try and figure that out. So there's 2 fewer lions, which means that there's less lions than elephants. So my elephants will go in the bar on the top, and my lions will go down below. I know that I have 5 lions and that it is 2 fewer. So now I need to solve to find my elephants. I have 2 addends, so I'm going to add them together to find my missing total. And 5 plus 2 is 7, so there are 7 elephants. Now we are going to practice answering some more problems about another graph. These problems might be a little bit trickier, and you'll see why. This graph is about Jenny's bead collection. She has 4 different colors of beads: blue, red, green, and purple. That's being displayed on the graph. And here's her question. Jenny has 4 fewer purple beads than Morgan. How many purple beads do Jenny and Morgan have in all? So my question wants to know how many Jenny and Morgan have in all. So their total. But I only know how many purple beads Jenny has. So this problem is going to have 2 parts in order to solve it. Because first I need to figure out how many Morgan has before I can add Morgan and Jenny together. Now I know that Jenny has 4 fewer purple beads. So Jenny has less. So we're going to put Morgan's comparison bar on the top, but we don't know how many Morgan has. We do know how many Jenny has because I can find that information over here on my graph. Jenny has 6. We also know it's 4 fewer. So the difference between both numbers is 4. Now I can write an equation to represent these comparison bars. I have 2 add-ins, so I'm going to add them together, and 6 plus 4 is equal to 10. So Morgan, we now know, Morgan has 10 purple beads. That was part 1. Now we can do part 2 and solve how many beads they have in all. So we're going to make a math mountain. Morgan has 10, Jenny has 6, and then those are 2 add-ins. So we're going to add them together. 10 plus 6 is equal to 16. So together they have 16 purple beads. Let's try another one. We're going to use the same graph, the same data again. 5 of Jenny's beads are large and the rest are small. She buys some small yellow beads. Now she has 18 small beads. How many small beads does she buy? Well, this one's a little bit trickier because in order to be able to figure out how many she has that are small to begin with, we need to know the total number. And then once we figure out how many she has that are small, then we can figure out how many more small ones that she buys. So let's start with just figuring out her total number of beads. So I have 7 plus 2, that's 9, and 6 and 5 is 11, and 9 plus 11 is 20. So I can just add those together. So I have 20 total beads. Now that I know that, I can get started. So this is really more like a 3-step problem. So now we're going to make a math mountain. We know there's 20 total. We know 5 are small, or I'm sorry, 5 are large, and an unknown amount are small. So we can add up, or that's one of our math facts that we should know. So 20 minus 5, we have a total minus an addend, is equal to 15. So now I know that there are 15 small beads. Now that I know how many small beads I started with, I can add the sum small beads that she bought and see that I have a total of 18. So let's make a math mountain. We have 18 total small beads. She started with 15 and she bought some more. That some more is our unknown. We don't know how much that is. So now we can add up to find our difference between 18 and 15. So let's see how many ones we need to add to get to 18. So we're going to start at 15, 16, 17, 18. So I need to add 3 to 15 to equal 18, which means that there are 3 small yellow beads that she bought. That was a tricky problem. Oh, look, our next problem is a puzzled penguin. Let's see where he made his error. The question is, how many more children choose fruit than nuts? And then I have a graph that has data about the children that like nuts, grapes, apples, and pretzels. So the question is asking us to compare fruit to nuts, but I don't have fruit on my graph. I do have grapes and apples. So I'm going to have to combine both of those. Now, if I look at those and I compare that to what Puzzle Penguin did, I know that apples alone is 8. So to have just 8 for apples is not going to be enough because that doesn't include my grapes too. So that is where Puzzle Penguin made his mistake. This is actually a two-part question. And in the first part, we need to find the total of our apples and our grapes. So we have 4 grapes and 8 apples. So I have 2 add-ins and a missing total. So I'm going to add 4 plus 8 equals my unknown total. And my unknown total, 4 plus 8, is equal to 12. So I actually have 12 children who chose fruit. Now that I know that there are 12 children that chose fruit, I can rewrite the comparison bars. So my fruit is equal to 12. My nuts is still equal to 5. And I want to know the difference. I want to know how many more children chose the fruit than the nuts. So I have a total minus an addend that's equal to an unknown addend. 12 minus 5 is equal to 7. So 7 more children chose fruit than nuts. Let's review our learning target for today. I can read and draw a bar graph to represent a set of data and use it to solve a problem. Let's do that one more time with our mirror words. Mirrors on. I can read and draw a bar graph to represent a set of data and use it to solve a problem. Mirrors off. Great job. Remember to go teach that to someone today. Thanks for coming and learning with me.